Hi, welcome back to Year 10s. We're up to exercises 5A and B today, a bit of expanding using the distributive law and some factorisation that you will hopefully remember from last year. You can read through the learning intentions. It says exactly what I've just said there. Quick refresh of some terminology. Like terms with exactly the same pronumeral form. X and X, they're exactly the same, so they can be added or subtracted. Also here, a squared b and ba squared, even though they've been written the other way around, they are still the same. That's two a's and a b being multiplied together. So they are like terms, and I could add 4 plus -7 to get -3 lots of a squared b. The distributive law, we know how to do that. Everything in front of the bracket multiplies everything inside the bracket. When you have two brackets, make sure that each term multiplies. Each term in the first bracket multiplies each term in the second bracket. Remember, they are binomial products. Binomial, two names or two terms. That's where that comes from. Perfect squares, we need to know these, and we need to know these really well. Unfortunately, too many of us make mistakes with this. Let's just refresh ourselves. I'll do the second one. A minus b squared. Why does that end up looking like that? If we draw a minus b times a minus b. A grid method is often a good method for multiplying out these things. It's perfectly fine just to use FOIL or some other thing. FOIL, of course, only works when they're binomial. If you have more terms, it gets confusing. This method you can extend with extra terms. Let's just double check and see how we could expand that. A times a will give me a squared. A times negative b is negative ab. Negative b times a, that's a negative ab. And negative b times negative b, that's a positive b squared. So inside the grid there, we have our solution. A squared minus ab minus another ab, well, that's minus 2ab. And then we've got a b squared at the end. So easy enough to follow there. That pen feels a little bit thin to me. I don't know how it's showing up for you. I'm just going to make it a little bit thicker though. We'll keep going. Difference of perfect squares. Why are they calling it dots when it could be any two squares? I'd always change that to dots for two squares. Or I'd just say your favourite rule in maths, because that's what it is. It's going to save you more time than any other rule in maths while you're at school. So you will hear me say your favourite rule from time to time. I am always referring to the difference of two squares. We used it when we were rationalising denominators just last term. So already should be comfortable and familiar with that. Let's go ahead and do a few examples just to make sure we're all okay with these. There are some there for you to try. I'm going to do the ones on the left first though. So let's see, -3 multiplied by x minus 5. So -3 times x, -3x. That negative still belongs with a 3. -3 times -5. Negative times a negative is a positive. 3 5s are 15. Let's have a look at the next one. 2x times 1. Well, that's just 2x. 2x times negative x. Positive times a negative is a negative. Number times number, so it's 2 times 1 is 2. And x times x, x squared. 2/7 multiplied by 14x. Remember, I can cancel. 7 goes into 14 twice, so that's going to make my life a little bit easier. So it's going to be 2 times 2x is going to give me 4x for the first term. 2/7 times positive 3. Nothing to cancel there, so top times top. 3 times 2 is 6. And 7 times, remember that 3 is over a 1. 7 times 1 is 7. So the answer to that would be 4x plus 6/7. Lucky last, this one might take a couple of lines rather than doing what I've started doing there. Let's do it down the bottom. X times 2x, 2x squared. X times -1, negative x times 3, -3x. And negative x times negative x, positive x squared. We have some like terms, we better gather them together. 2x squared plus another x squared, that's 3x squared. Negative x, take away 3x, that's -4x altogether. All right, you've got some there to try. Pause the video and try them now. I will come back with the answers as soon as you click on unpause. See you in a second. All right, hopefully your answers match the ones that I have there. Just pause and check, and then we'll move on. Expanding brackets. So I just like to remember the rule. I can do that grid that I showed you earlier, but let's just see how we would go. Eventually, you're expected to be able to do this. So x times x is going to give me x squared. What about the middle term, the x term? Well, I'm going to get 4 of them with the first x times a 4. Another 5 with 5 times x. Altogether, that's going to be 9x. And then 5 times 4 is 20. X minus 4 all squared, so it's the first term squared. x squared minus 2 times the first term times the second term. So it's going to be minus 2 times x times 4, so that's minus 8x. And then it's plus the last term squared. 4 squared is 16. So x squared minus 8x plus 16. Lucky last one here. Oh, look, it's my favourite rule in maths. 2x plus 1, 2x minus 1. That's the difference of 2 squares. Make sure that you're thinking about doing this correctly. I'm happy for you to skip that line as long as you remember 2x when I square it gives me 4x squared. Minus 1 squared is 1. You've got a chance to try the others again. I will pause. Please make sure you do them first and then double check. See you in a second. And hopefully you've got matching answers there. You've seen some like these. The first one there, I'm not going to do A again. B is pretty straightforward, but I might as well do, I think I'll just jump to C and do that. And if you can follow what I do in C, you can always go back and check those A and B in these next examples if you want. So what do I get when I'm expanding C? Well, I get x times x is x squared. How many x terms will I have? Well, I'll get 2x from that pairing, and x times 4 will give me another 4, so that's 6x altogether, plus 8, minus, now it's really important you keep a bracket here. This is where a lot of students end up giving away marks. I think I'm going to expand to get rid of those brackets, and you are, but this entire product is being subtracted, so I need to make sure I continue to subtract that. So what am I going to subtract? X times x, that's going to be an x squared. Minus 2x minus another 5x is minus 7x. Negative 2 by negative 5 is plus 10. And now it's just a matter of equating like terms. So x squared minus x squared, they're going to disappear. 6x minus negative 7x, that's 6x plus 7x, 13x. And 8 minus 10, negative 2. That x did not look a lot like an x. Hopefully that looks a little bit more like an x to you. 13x minus 2. I think it still looks pretty messy. Try and have some pity on you. Maybe you'll have pity on me when I'm marking your exams. Have a go at those three. Do all three of them. You didn't need to see me do them again. I'm confident you'll get them right. I'll see you in a second. And there are your answers there. Again, racing through this work. It's very familiar to you from what we've been doing last year as well as this year. We're going to do exercise 5B as well here. Let's just have a look at some factorising. Taking out common factors here, I've got 3 is definitely a common factor of 3 and 12, but I want to take out negative 3 because they both also have a negative term. So if I take out negative 3 as a common factor, what would be left in the first term? It would just be x. And in the second term, it would need to be a positive 4. Check when you expand, negative 3 times x, yep, negative 3 times positive 4, negative 12. You know you've got it right, which is always a good thing. The next one here, highest common factor is going to be 10a. So the numbers, it's going to be 10. Then look at the letters, a squared and an a. The most they've got in common is an a. So you put that out the front. What's left over? Well, to end up with 20a squared, I would need a 2. So 2 times 10 would give me 20. And I'd need an a. And for the second term, 10a multiplied by 3 would get me to 30a. Lucky last one here. Sometimes you'll have the case where the brackets are the same. If that happens, that's your common factor. X plus 1 goes out the front. Common factor out the front. Remaining factors inside the bracket. So the first term has a remaining factor of 2. The second term has a remaining factor of negative a. So it would be x plus 1 multiplied by 2 minus a. There are 3 matching ones for you to try. Again, it's really important you try them just after you've seen them. Have a go, and we'll see you shortly. And there you have the solutions there. I'm pretty confident yours will match. If not, just check out where we went wrong. Try it again. Make sure you're okay with them. Moving on. Oh, our favourite rule in maths, difference of 2 squares. This is going to be so much fun. What do we remember here? Oh, 16 is just 4 squared, so this becomes x plus 4 multiplied by x minus 4. 9a squared b minus 4b squared. I'll put an intermediate step. I don't really have enough room to do one, but I'm going to put one in anyway. This is going to be 3a all squared minus 2b all squared, which is then going to let us simplify that to 3a plus 2b, 3a minus 2b. I said simplify, I meant factorise, of course, didn't I? Favourite rule in maths. I might have to do example C over on the side here. 12y squared minus 1200. if there's a common factor, take it out first. Always our first step whenever we're trying to factorise. Oh, look, and that helped nicely, didn't it? Because 100 is 10 squared, so this is going to be 12 outside of y plus 10, y minus 10. Lucky last one here, x plus 3 all squared minus 4. Well, 4 is 2 squared, so this is going to be fine. This is going to be x plus 3 plus 2, x plus 3 minus 2. I can go ahead and simplify now. That's x plus 5 multiplied, and 3 minus 2 is 1. So x plus 5 times x plus 1. There are some there for you to try. I'll come back later. I'm having so much fun. I'm going to keep going with the next one. Sometimes we have to use surds. We'd already mentioned that. 10 is the same as root 10 squared. So this could just be x plus root 10, x minus root 10. Sometimes you need to be careful. You may need to simplify. I'm going to do b over on the side here. X squared, take 24. I can definitely say that's the same as x plus root 24, x minus root 24. But being fantastic Year 10 students, you wouldn't be rude and leave your answer with a non-simplified surd. You would simplify that. Root 24, remember, is root 4 by root 6. Square root of 4 is 2. I could just write it as 2 root 6. That'd be a lot nicer, wouldn't it? So this is going to be x plus 2 root 6, x minus 2 root 6. And that's a nice answer there. Lucky last one here. X minus 1 all squared minus 5. So x minus 1 is my first term. Root 5 would be the second one. So I'm going to have x minus 1 plus root 5, x minus 1 minus root 5. Lucky last, sometimes when we have 4 terms, we can find a way to factorise. They don't have a common factor there. But if I pair them up, if I break them up into pairs, they may just work out nicely for me. Let's have a look and see if that does work out nice. If I factorise just the first pair, x is a common factor, and I'd be left with x minus 1. And the second pair, a is a common factor, and I'd be left with x minus 1. Ah, look at that. I've now created a new common factor. So x minus 1 is my common factor that goes out the front. What were the remaining factors? Well, the first term had an x, and the second term had an a. And that would be that term factorised. There are a few others there to check. I'll go and fill in the answers now, but I feel like you've done pretty well to make it this far in the video. This is really good practice. You need to be very confident, very fluent with these skills, so make sure you practice them. You're going to get them in your quick points again and again throughout the term, but just keep going with them. I'll pause now, give you a chance to check your answers. And there you have them. Just take your time to check those. Good luck with the rest of your work today. Just a few quick points, because I know you've had to do a few little extra ones with me during the video today. There's your basic training, your exercises, standard or standard and advanced if you're keen. And don't forget to fill in your form. Really good work. I know it's pretty much revision for this exercise. Good luck with that, and we will catch you in the next video. Well done, guys. Cheers.